Question number 21. A steel ball floats in water with its beam facing up. If water is poured slowly, which of the following figures shows its position at the verge of sinking? You know that when considering a floating container, the water level in the container should be always less than the outer water level, like this. When sinking it, the water level should be like this, and when sinking, water will enter to the container from this end. Water will enter to the container from its beam, and then it will sink it. Then we can get the answer is first one for the question number 21. We can't get another 4 answers. Then question number 22. The cork is attached to the bottom of the water beaker with a string so that it stays under the surface of water. The beaker is then rotated with a constant angular speed about its vertical axis. Which of the following figure indicates the correct position of the cork? We know that when rotating the system, the water level of the container will be like this because of centripetal acceleration. There is a centripetal force. Centripetal force should be given by pressure difference. Then water level at the edge should be a higher value than water level at the center. Then considering cork, we know that its density is less than medium density. Therefore, it should move towards the center like this. If the density of the object is greater than density of outer medium, it will move to the opposite direction of acceleration. But now the density of the object is less than outer medium. Outer medium is water. Density of cork is less than water. Therefore, it should move towards the acceleration. Then answer should be 3 for the question number 22. Then 23. A beaker contains 2 immersible liquids having distance d1 and d2. 3 spheres ABC of materials of densities dA, dB, dC respectively are released from the bottom of the beaker. If d1 is greater than dB, less than dA, less than d2, less than dC, we have to find the correct statement. Sphere C will reach the surface xy and come to rest. Now I will consider density. They have given d1 is greater than dB, less than dA, less than dC, less than less than d2 less than dc. When considering these four densities, the smallest density is dB. Density of B is less than all densities. Therefore, B should float in the beaker like this. B. And they have given density of A is less than density of second medium. Now D1 medium is this one, D2 medium is this one. When considering D1 and D2, D1 is less than D2. Now density of A is greater than dB, but less than D2. We can't compare density of D1 and dA because of D1 is greater than dB, dA is greater than dB. Then we have to consider the given statement. We can't correctly recite without using statement. But we know that density of C is the greatest density. dC is the greatest value in this system. Therefore, it is compulsory the sphere C should stay at bottom because of it has the highest density. Then we can get fifth answer is the correct answer. We can't get 1, 2, 3 or 4 without using values, but we can identify density of C is the greatest value. Therefore, sphere C has the greatest density. Then it will stay at the bottom. Then fifth answer is the correct answer. It will not move in upward direction. Then question number 24. Figure A shows the balanced position of a light rod carrying an object X and a mass capital F. Figure B shows the balanced position of the same system when X is immersed in water. If the density of water is D, the density of material made of X is given by. We have to find the density of material. We can consider the first situation. In the first situation, there is an equilibrium. We can write torque around point A. There is a system like this. When system at the equilibrium, they have given balance length L and L1. Now I will consider torque around this A point. Mass of X into length should be equals to M into L1. X is the mass of X. I will consider it as mx. Now I will get it as simple M. It is the first equation. Now for the second situation, we know that when immersing this weight in water, there is an upthrust. Therefore, we can consider weight and upthrust. Now, we can get another relationship. Balance length is L2. For this situation, we can get that upthrust on the object, upthrust into length. It is the torque given by upthrust for the object X should be equals to decreasement of torque in counterclockwise. We can consider equilibrium of the system, or we can consider change of torque in system. I have considered change of torque. Now mg and capital MG are weights in this system, but there is an upthrust in clockwise direction. The clockwise upthrust should be equals to decreasement of torque due to upthrust equals to decreasement of torque in counterclockwise direction. Then we can get torque due to upthrust is U into L. It should be equals to decreasement of torque in counterclockwise direction, mg times L1 minus L2. mg times L1 is the initial torque and m into L2 is the final torque. We have to subtract it to get the difference of torque. Difference of torque equals to torque due to upthrust. Now we have to find the density of material X, density of the material made of X. Now we can divide equation. When dividing, we have given that density of water is D. We can write upthrust as V D G. We have given that density is D. Density of water, mg into L1 minus L2. Now we can cancel out G, then we can get it as the second answer, second equation. This one is the first equation. Now I will divide first equation and second equation. First equation divided by second one. We can get mass L is cancelling, divide by Vd equals to capital M is cancelling, L1 over L1 minus L2. Now we can substitute simple M means mass of X. Mass of X is, we know that density equals to mass divided by volume. Now we can subject mass. Mass equals to density into volume. Now I will use it for the simple M value. Density into volume divided by volume into density of water in the denominator equals to L1 over L1 minus L2. We can cancel V. Now we have to subject rho value. Rho equals L1 over L1 minus L2 times D. L1 over L1 minus L2 into D. Answer is 1 for the question number 24. Then question number 25. Two cubes A and B of the same geometrical dimensions floating in water as shown in the figure. Cube A has half of its volume above the water level, whereas B has only 1/4 of its volume above the water level. If the cube B is carefully placed on the cube A, which of the following responses indicate the correct position of cubes A and B? Now cube B is carefully placed on cube A. Therefore, it is compulsory cube B is carefully placed on cube A. Therefore, cube A should fully immerse, completely submerged in water. And we have to find the immersed portion of cube B. Now I will consider the system is like this. same dimensions. Cube A completely immersed and cube B is like this. When comparing masses, we can consider that mass of B should be, we can get it, weight of B, MBG, should be equals to upthrust on B, half V rho G. When considering first situation, mass of A, weight of A equals half of V rho G. V is the volume of a cube. But MBG, weight of B, should be equals to 3/4 V rho G. They have given immersed volume for the object A in first situation is half. Immersed volume of the object B in the first situation is 3/4. When considering sum of weights, we can get sum of upthrust. For this system, we have to consider the sum of upthrust. Therefore, we have to add these two values. I will add these two values. We know that 1/2 is 2/4. 2/4 plus 3/4. It means 5/4 V rho G. Now, when considering this A cube, by immersing it, it will give an upthrust V rho G. V means total volume of cube A. And the remaining upthrust should be given to the system by immersing B. Remaining part is 1/4 V rho G. You know that sum of these two terms should be equals to 5/4 V rho G. Then this 1/4 V rho G upthrust is given by B. Therefore, 1/4 of the volume of cube B should be under the water. Answer is 3. 1/4 of cube B should be immersed in water. Then question number 26. The force of 10 Newton is applied to the smaller piston P of area 2 square centimeters of the hydraulic system shown in the figure to produce a force F1 on the large piston Q, area 4 square centimeters. Solidified block moves freely inside the system and new force produced on Q due to the force 10 Newton becomes F2. The respective value of F1 and F2 are. There is a F force at P end and it is a hydraulic system. For the hydraulic system, we know that pressure is equal in same liquid at same level according to the Pascal principle. Therefore, we can get force F, force at this space F1. We can equal pressure for this point and this point. Pressure at P should be equal to pressure at Q. We can write pressure is force divided by area. Therefore, if force divided by area of P piston 2 square centimeters, I will use square centimeters because of the unit in both sides square centimeters. We can cancel out it. Pressure at Q, F1 divided by 4 square centimeters. Now they have given F force is 10. 10 divided by 2 into 4 equals F1 divided by 2, 1, 2. 10, 20 Newton. F1 force is 20 Newton. Now they have given that when the surrounding temperature is decreased, the liquid inside solidifies. The solidified block moves freely inside the system and new force produced on Q to the force F equals 10 becomes F2. Now we know that for a solidified object, this F should be equals to force at this side. We can't get Pascal principle. It is a solid object. Therefore, we can consider for the solid object F2 equals F. It means 10 Newton. Then 20 Newton and 10 Newton. Answer is 2 for the question number 26. Then question number 27. A uniform metal cylinder of mass capital M hangs from a spring balance A and is lowered slowly and steadily into a water container of mass capital M. Capital M is greater than simple M until it rests totally submerged on the bottom of the container. The container is placed on the pan of the weighting scale B as shown in the figure. The variation of readings of A and B with time are best represented by. There are two balancers. B is this one and A is the spin balance. Like this. Now we have to fully immerse this object in water. For the initial situation, there is a mass reading. Capital M mass is greater than simple M mass. It is given in the question. And when immersing this object, we know that there is an upthrust. I will consider when it is at a level like this. For this object, weight, there is an upthrust. And when considering outer system, it means container, capital Mg, and there is a down thrust. We can get equal and opposite down thrust on the water. According to this one, the reading of A scale should be decreased. Then reading A is decreasing, but reading B should increase because of there is a down thrust. Then reading B is increasing with immersed volume. And when fully immersed object, when considering fully immersed object, again it is constant. There is a full upthrust on the object. It means there is a full down thrust on the water. For the scale M, it is opposite. Simple M is decreasing and constant. Then now there are two answers like this, second one and third one. But for the final situation, in second graph, they have given that M is increasing like this and simple M is decreasing like this. It means meaning of this part. When this object is touching bottom of the surface, tension of this cord is 0. It will 0. Tension of cord, this cord will be 0 at when touching this object at the bottom of the surface. Therefore, reading of this scale should be 0. When reading of this scale is 0, the full weight of this object is acting on this system. Therefore, its mass reading of B will be increasing like this when touching the surface. Then correct answer is 2 for the question number 27. 28. A metal block is suspended at rest below the surface of water in a tank as shown in the figure. When the block is released, it falls to the bottom of the tank. Consider the following statements. When block is released, it falls to the bottom of the tank. It means density of the metal is greater than density of water. Statement A. The block gradually loses its gravitational potential energy as it falls. Yes, we know that when considering falling object, it will be a free fall or any other fall. Falling object, gravitational potential energy is decreasing. Then A statement is correct. A is correct. B. Although the height of water level does not change, the water gains gravitational potential energy. Yes, we know that when considering the given situation in the figure, the object is fully immersed in water. Therefore, water level will not change. B also correct. C. If water was not present, the kinetic energy of block at point A would be less than at A when water present. If water was not present, the kinetic energy of block at point A would be less than the at A when present. No, if water was not present, kinetic energy should be greater than, because of we know that when considering moving object in liquid, there is a resistive force. Therefore, when passing point A, kinetic energy should be a greater value if water is not present in the container. Then C is incorrect. Only A and B are true. First one is answer for question number 28. In 29, as shown in the figure, a small beaker containing a piece of wood and piece of stone floats in water inside the large beaker. The density of the stone is larger than that of water, and density of the piece of wood is smaller than that of water. Consider the following statements made about the height h of the water level inside the larger beaker. Part A. When the stone is taken out and dropped in water, h increases. Now we know that for the given situation, there are two blocks inside the small container. In first statement, when the stone is taken out and dropped in water, density of stone is greater than water. Density of stone is greater than density of water. Therefore, when getting stone and put it to the water surface, it will fully immerse in water, and the upthrust, new upthrust on stone should be less than old upthrust on stone, because of the stone will immerse in water. For this situation, stone is floating because of it is in the small container. New upthrust is a small value. Therefore, displaced water volume. Water volume is a small value. Displaced water volume is decreasing. Therefore, simple H value is decreases. It is correct. Then statement A is correct. Then statement B, when the piece of wood is taken out and put it in water, it remains unchanged. Yes, we know that when the wooden block is getting out and put into the water, it will float. Therefore, same condition for this situation, and when wooden block is in the outer medium, there is a same upthrust, because of for the both situations it is floating. Therefore, there is a same upthrust. Simple H value, displaced water volume will not change. We also correct. C, when the stone and piece of wood are taken out and tied and then put it water, if they go to the bottom, beaker H will increases. No, beaker H water level should be decreases according to this same theory. C is incorrect. Only A and B true. True for the question number 29. Then question number 30. Three masses made of materials having densities ρ1, ρ2 and ρ3 of equal volume are connected together with large string, the system floating at vessels containing two immersible liquids of densities ρ4 and ρ5 with strings as shown in the figure. We have to consider correct statements. They have given in the first statement, statement A. Density of 1 is less than density of 5, ρ5. ρ5, yes, we know that it is ρ1 object. Is in the upper medium, therefore its density should be less than ρ5. Medium means down layer. Therefore A is correct. B, ρ1 is less than ρ3. Yes, it's also correct. If ρ3 is a less than value, the system should be in opposite direction. ρ3 object should be the upper object. It is correct. B also correct. C, if the tension of the strings are equal, ρ2 equals ρ5. Tension of the strings are equal. It means we can consider, we know that these two objects are in the same medium. These are strings. Then if the tension are same, it means it is like a same object, same string. both the strings are acting as the same string. It means we can consider this object is removable string, removable object. Therefore, it means there is no an upthrust or weight acting on this object. It means it is equal to the outer medium. Then outer medium is rho phi. Rho phi should be equal to rho 2. Then C also correct. A, B, C all true. Then fourth one is the answer for question number 30.